Good evening, Sam. Now let's start the class, please. Get ready for it. So now look at it. Starting the session. Now look at it. If somebody will be asking you this question, last class we have studied about work, and in that we have studied that work is exactly how work is done. Different type of work is there. We were understanding that work can be done when energy will be possessed inside the body, then work will be done. That's what one definition of work we have done. Okay. Now we are going to go for the next part. Everybody, please join as fast as possible. Yes, beta. Sam, last class we have studied how much is there. In that we have learned that work is of three types: positive work done, negative work done. Understood not? So there are different type of work done. So first part is if somebody will be asking you how many type of work is done, means your answer should be there are three different type of work. One is positive work done, second one is negative work done. So we must be understanding this type zero work done. And last class itself we have learned that when the work done will be positive, when the work done will be negative, and when the work is supposed to have zero value. Understood? In that all section we have done that part. Wait. So this is exactly one thing. Now we are going to understand positive, negative, positive work done. So last class we were having a discussion about positive work done. In that positive work done session, we have understood that when work is said to be positive, if the applied force, means the force which we are applying is in the direction of displacement. So when the force is in the direction of displacement, when the force is in the direction of displacement, then it's supposed to be a positive work done. Understood? Now look here. So net force, when it is going, it will displace, the velocity of the object will be toward this direction. So this is considered as positive work done. And the body will have, see, this is the initial velocity and this is the final velocity. So the body will have a movement beta. So when the body will be, Sam, can you inform in the group that class started? So when the body will be having a movement, it will be considered as positive work done. It will be considered as what? It will be considered as positive work done. Understood? So work done by horse pulling a cart, or means when the horse will be exactly pulling a cart, that time it is supposed to have a positive work done. So work done by gravity is also considered as positive work done. So these are some examples of positive work done, beta. Yes. Positive work done. So this type is exactly considered as what, beta? Positive work done. So work done by the stretching force acting on a spring is also considered as a positive work done. So when positive work done, and which one is negative work done? Understood or not? Nobody else is there in the group. So this is exactly the example of positive, negative. So now I'm going to go start teaching. I have informed everyone that class timings and all. Just last one timing I have to inform, beta. Just one last timing I'll inform and I'll do my work. Good evening, beta. Today I am sorry. I am feeling very sorry, beta, because most of the time the timings were going very bad today. So definitely timing was so problematic, and I was like full day here and there. After classes in between, gap was there and problem was created. So most of the time network problem was there, and I suffered a lot. Now only I started class for ninth. Now after that I am having two more classes. Now I will have class with seated, then I am having class with 11th class. So definitely two, three more classes are there. So now look it up. We are going to go back to the work done by gravity if the body falls towards the earth. So if any object will fall towards the earth, it will be considered as a positive work done or a negative work done. The correct answer, it will be considered as a positive work done. So any object will fall towards the gravity, it will be considered as a positive work done. So work done by pulling a cart. So if somebody will be asking you what is the work done by a horse pulling the cart, it will also be a positive beta, because where the force is applied, there the object will be exactly moving. So that the object is exactly moving in the direction of force, so it will be considered as a positive work done. Okay, now work done by stretching force acting on a spring. So when one spring will be there and you will be exactly applying the stretch force, the stretch force will be coming down. Again, it is a case of what? Positive work done. Okay, so we have understood this part. Now we will go for the next one, negative work done. So when somebody will be asking you about negative work done, so when the work done will be negative, so you must understand that friction is negative. Okay, like friction will try to oppose the motion of the object. You want to take the car in another direction, and the friction will try to stop the motion of the car. So friction is always the opposing force. Friction is always considered as what, beta? Opposing force. It is opposing the motion. Okay, so work is said to be done negative if the applied force is in the direction opposite to that of displacement. Displacement is another direction and force is opposite direction. So that's why it is considered as what? It will always be considered as a negative force. So work done by braking force. So work done by the braking force, when brakes are applied to the vehicle, definitely when brakes will be applied to the vehicle, that time it is a negative work done. Work done by friction is a negative work done. Work done by the Next one is work done by the force of gravity when the body is projected away. So when the body is going away, that time it is considered as a negative work done. I hope you might have understood. So negative and positive work done, I hope you children are understanding. When the work done will be, if I am throwing something up, it is negative work done. If the object is going down, it is positive work done. I hope you might have understood till here. Okay. Now listen, we will go for the next one. Zero work done. So when can an object is not doing any work? So according to physics, if I'm standing here, I'm not at all moving, means I'm doing zero work done, because I'm not at all moving. So I'm standing here, there is no displacement done by B. So definitely I'm doing what? Zero work done. I don't have any work done here, but here we are going to understand this. So work done is said to be zero if the applied force is zero or displacement is zero, or the angle between displacement and force is 90 degree. We already told you that work and displacement scalar product is there. So scalar product means what here? So if somebody will be asking you scalar product means here that the dot product between them is making 90 degree. Force and displacement will be 90 degree. How it will be? Let's check this one out. You understand this, beta? This is exactly force and this is displacement. So force and displacement becoming perpendicular to each other. So when force and displacement are perpendicular to each other, work done is equal to Fs cos 90 degree, and cos 90 degree value is 0. So this cos 90 degree value is 0. So it will become Fs into 0. Answer is coming as 0. So work done will become 0 here. This you please remember. So when work done will be 0? When force will be perpendicular to displacement and displacement will be perpendicular to force. At that particular moment, when the force and displacement are perpendicular to each other, then work done will become 0. That time what is the work done? That time the work done will be considered as 0. So work done by the tension in the string of a simple pendulum is exactly perpendicular. Now I already told you कि when we will be talking about a simple pendulum, the pendulum will be hung like this, Now check this one out. This is exactly the way I'm hanging a pendulum. The pendulum will have to and fro motion. Understood? The pendulum will go to this location and then it will come to this location. It will keep on swinging like this. Swing, swing, swing. Understood? So this is exactly the motion. Hi Ruchi, very important part work done के बारे में पढ़ा रही हूँ, उसको ज्वाइन करो. इसके बाद सीधे 7:30 डायरेक्टली क्लास शुरू कर रही हूँ मैं. ठीक है? So this is exactly about the work done. So if somebody will be asking you about the work done here is like to and fro motion will be there, to and fro motion coming in this position. Okay, to and fro motion coming in this position. It will be exactly what type work done. It will be considered as see when you will be exactly going like this. So here work perpendicular, force and displacement is perpendicular. So once the force and displacement will go perpendicular to each other, the work done will become zero. So work done by the tension in the string and the displacement. So definitely it will be coming as perpendicular to each other. So work done will become zero. Now work done by centripetal force. Here centripetal force will be central. It will be centripetal force will whenever it will be the tangential force. So 100% again it is going to be zero. Work done by coolie carrying load on his head. So if any coolie is carrying load on his head, that time the work done will be exactly coming as zero. Understood. So that time the work done will be coming as zero. So this are work done by a coolie carrying load on his head. This is again a type of what? This is again a type of what you call zero work done. It will again be a type of zero work done. Okay. Just 1 minute, beta. Hello. Ah, sir, I'm in live class, sir. What happened, sir? हाँ yes sir, sir 5 minutes means once class is over I'll call you sir. Okay sir. Okay, so this is work done by a coolie carrying load on his head. So whenever the work done, the coolie carrying load on his head will be again perpendicular. So this will be again what type force? Zero force. So if I'll carry something on my head, work done is zero. If centripetal force, work done is zero. Tension, bob and pendulum, work done is zero. So and when force will be perpendicular to displacement, work done is zero. So I have given some examples where work done can be zero, positive and negative. Frictional force, positive, negative or zero. Come on, say. Frictional force is positive, negative or zero. Come on, say. Frictional force, if somebody will ask from you, is it going to be positive, negative or zero? If anybody will ask you about frictional force is going to be positive, negative or zero. Come on, say. Negative, absolutely. Frictional force is negative force. So if somebody will ask you about frictional force, we can say that frictional force is negative force. If somebody will ask you any object going up, so if any object is going up, that time force will be positive, negative or zero. If I'm throwing something up, is it going to be positive, negative or zero? Something is going up. Is it against the work done or it is towards? So what type force it is? Understood. So what type force it is? Positive, negative or zero? Very good. So if anything will be no against gravity, if any object is going up, that time it will be negative work done. You need to remember that if any object is going up against gravity, that time it will be considered as negative work done. Work done by the tension of the wire on the string, so definitely it is considered as negative work done. You need to remember all these points. So this part will be considered as positive, negative work done means this will be considered as negative work done. Now we will be going to the next section. So this part I hope you might have understood already. We had a discussion about it. Now with a force acting on a body will always make one angle. So I did discuss about force and displacement. In that I have discussed a very important thing, like whenever any object will be moving, so resultant we need to understand. So like whenever we are talking about force, what it will be acting on a body and it will make some angle with the horizontal part. Understood? The horizontal component of the force will be exactly coming as f cos theta and the vertical component will always be coming as f sin theta. So now let's see if horizontal or vertical component is here. It's not shown, so I'm going to show you. This is exactly going to be the force and displacement part is there. One thing I'm going to show you, just check this one out, beta. So if this is exactly, this is called as vertical section. If any object force will make some angle with the displacement. Okay, remember this part. So this is exactly called as horizontal vertical, and this part is called as horizontal. This is horizontal and this is vertical. So beta vertical it will become f sine theta and horizontal it will become f cos theta. Understood? So force resultant part f cos theta and f sine theta will be there. You must remember one part will be considered as f cos theta, another part will be considered as f sine theta. So whenever we are writing force, we will be sorry work done will become what f cos theta into s. Cross product will be exactly coming as s. So please remember this part. Please remember this part. So now let us consider the following cases. So now this is the formula. Understood? So this is exactly the most important part. We had to remember this section. So now let us consider for the following cases. It will be considering as f cos theta into s part will be there. So this is exactly going to be the work done formula, and this is the way to proceed and write the formula. I hope till here it is clear, beta. I talked to you, I told you two component force will be divided. One horizontal component, this will become F cos theta. Vertical component, it will become F sin theta. Because since the force will be exactly in the direction of displacement, I repeat, since the force will be in the direction of displacement, so this angle theta is going to be the determining part. Understood? This angle theta will become the determining section. Now let's go for the next part. So now you understand when angle theta, that's what I have made now. I made angle theta part now. So this is what I told, given theta will be less than. So if this is theta, so if this theta will be less than 0 to 90 degree, work done will be positive. Okay. So when the theta value means, what is the formula for work done? Work done is equal to F cos theta into S. Now we take this angle theta, if this angle will be 0 to 90 degree, work done is positive. This part will become positive. Understood. So now if this theta will be equal to 90 degree, strictly I can write here from 0 to closed interval, open interval. So now here work done will become equal to 0. Now if theta value will be greater than 90 degree and less than 180 degree, less equals 180 degree, work done will be negative. Understood. So this is exactly the angle distribution. So if this theta will reach to this part, vertical statement, then that time it will work done will become 0. But if the same theta will cross and it will come to this region, the work done will become negative. So that's the most important part. When the work done will be positive, when the work done will be negative, and when the work done will become 0. So come on children, can you tell me among which value to which value work done will be positive and which value to which value work done will be negative? I hope till here it is clear to you. Okay, till which value? 0 to, see this section when it is coming means, so that means what beta, I hope till here everything is okay. I hope till here everything is okay. So if somebody will be asking you theta value lies between 0 to 90 degree, means work done is positive. 90 exactly. Work done will become what beta? Work done will become, yes, super beta. So work done will become 0. And if it is greater than 90 and less than 180 degree, that time the work done will become negative. So this is the angle. So whenever Fs cos theta, but usually beta for your class, we are writing work done is equal to force into displacement. We are not, if angle will be considered, if force and displacement will subtend some angle, that particular moment we will write like this, then we will check the angle. Understood? But if they will only give you, listen to me nicely, if they will only give you force and displacement, then writing work done formula will become very easy. I hope you might have understood till here. Till here, is it okay, beta? Hmm? So work done formula, writing the work done part is very, very important, and you must have to notice this section, like how we are going to proceed this section. Is it okay? Yes. So we will proceed to the next section, beta. We'll go for the next section. So now we are going to study this part again. If 0 to 90 it is coming, cos theta is positive. So work done is positive. If theta is equal to 90 degree, work done is 0. If it is greater than 90 degree, less than 180 degree, then work done is considered as negative. This is what I taught you. Okay. Now we will go for the next part. So when next part we are doing, so work done will have different values, beta. So this section question, if it is not in NCRT, but for competition purpose, cos theta value, like cos 30 degree value is root 3 by 2. In class 10th, you are going to study cos 45 degree value is 1 by root 2. Cos 60 degree value is 1 by 2. Cos 90 degree value is 0. Cos 120 value is 1 by 2. Cos 135 is 1 by root 2. Cos 50 is 1 minus 1 by minus root 3 by 2. And cos 180 degree is minus 1. So these are some of the angles, beta, and they are specifying positive, negative, and zero work done. You see here, this is a case of zero work done. Now, when force and displacement are perpendicular to each other, that particular moment, the work done will become what? The work done will become zero. Now here you see, beta, when the force and displacement, see, force applied and displacement is here, but this angle with the positive direction of x-axis is coming more than 90 degree. This is the angle, because you see, beta, force applied, object moved like this. So angle subtended, this is the positive direction of x-axis. So from the positive direction of x-axis, whatever angle subtended is greater than 90 degree. So whenever theta value will be greater than 90 degree, work done will be negative. And here you see the force of application, force applied, displacement in this direction, and displacement is less than 90 degree, beta. So it is going to be acute angle, and work done is positive. This is a very important part we have discussed about positive, negative, and zero work done. Okay, and this is what the explanation is given, and this explanation already I have discussed with you. Okay, now I'm asking you one question. If you people are listening me, please answer. My question is, first question is, can you give me two examples of positive work done? Give me two examples of positive work done, beta. Two examples of positive work done. Till here, is it understandable for you? I hope you might have understood when the work done can be positive, when the work done can be zero, when the work done can be negative. Now, work done, I just asked you one question, two examples of positive work done. Lifting a box, positive work done. I. Stretching string is the correct answer. Lifting a box, pen falling towards earth. Pen falling towards earth, positive work done. Stretching string will be positive work done. Kicking football, positive work done. what you called letting a cart come towards you by putting for what you call force, it is exactly going to be a positive work done. Example of negative work done. Can you give me some examples of negative work done? Come on, children, you can do it. Give me some examples of negative work done. Come on, beta. Give me examples of negative work done. Examples of negative work done. When can you say that the negative work is done? Riding bicycle. Negative work done is riding a bicycle. Okay, fine. How riding a bicycle is negative work done? The answer is absolutely correct. Riding a bicycle means frictional force will be there, and when frictional force will be applied means the direction of object movement is different, and the object is going in opposite direction. That time it is considered as a negative work done. Absolutely correct. Negative work done. Whenever any vehicle is moving, frictional force is a negative work done. Absolutely correct. Next, if I am throwing any object towards like up, so if any object is going up, it is a case of negative work done. Absolutely. So walking on road is a negative work done. How walking off road forward movement is a walking off road, walking on a road is a negative work done. How? Hmm. Frictional force again and again I'm telling it is a case of negative work done. Let's talk about it and we'll go for the next part. Now better look here. We are going to talk about since we have understood that ki work done. Good evening beta. Today network was so mama. I was like very struck and then 12th class started. 12th class timing came. 11th after teaching in between session itself logged. Somehow tried to take out and then started class. After 12th directly I started teaching 10th. Now I will teach another class. Understood? So now better look here. So positive work is where the force pull is in the same direction that already we have done. Force is in opposite direction negative and horizontal direction. So when the force is applied on horizontal direction, you see whenever the force will be applied on horizontal direction, it is a positive work done. So now look here. This is what we were discussing now. When force is applied on the body in such a way that the body suffers a displacement. Suffering a displacement is there. But I told you now, this direction will become F cos theta, this sorry F sin theta, and this direction will become F cos theta. Angle subtended is the most important part. If angle is acute, then it is positive work done. If angle is obtuse, more than 90 degree, more than 90 degree like this direction, then it will become negative work done. And if the angle will be directly coming here 90 degree, then it will become zero work done. Understood? So these are some of the situations of work done. Now formula, this is the second time I'm explaining. I already explained the formula here. Yes beta. So this is the way to explain and understand the formula. Now everybody's think like if force is a vector quantity or a scalar quantity. Today is Kartiki. Hmm. Seriously, I forgot. Yeah. Good evening. Force is a vector quantity. Absolutely correct. Force is a vector quantity, beta. That is one thing. Now we know that cos theta is equal to, so whenever you will be writing, force part AB is equal to horizontal and vertical part already I have discussed. They have just elaborated it. When this PDF will be releasing to you, if PDF will be going to you, that time you need to write down. Now that much is not enough. Only that part I have written, that section is more than enough. Don't go for beyond that part. This much is enough. How much I gave you now, how much statement I told you, that much is enough. This has extra. So now look here, between CGS system. We need to understand that CGS system is there. So in CGS system, what can be work done? Okay. In CGS system, what can be work done? We need to understand this. Now look at beta. In CGS system, if somebody will ask you the absolute unit of work is erg. So now in CGS system, erg is the unit in which work done is exactly written. I'm teaching grade 9 work and energy. You're in which class, sir? So definitely it is in CGS system, if the work done is negative, CGS system, what is the unit of work done? It is erg. And 1 erg is equal to, if somebody will be asking you, 1 erg is equal to 1 erg. Oh, 1 erg. So 1 erg. So if somebody will be asking you 1 erg, so 1 erg is equal to 1 gram square centimeter per second square. 1 gram square centimeter per second square. Understood? This is exactly about 1 erg. In SI unit system of work is joule. So 1 joule will be equal to how much beta? If somebody will be asking you in SI system work the unit is joule. So 1 joule is equal to how much it will be? 1 kg. 1 joule is equal to 1 kg meter square per second square. 1 joule is equal to 1 kg meter square per second square. Now, if somebody will be asking you what is the relation between Newton and all that part, so we know that what is the relation between Joule and Newton, erg. So you need to understand that first Joule and erg relation. Okay, so if somebody will be asking you how to write the relation between Joule and erg, so already we know that. See, 1 joule is equal to how much meter? 1 joule is equal to 1 Newton into 1 meter. So 1 Newton is equal to 1000 to the power 5 dyne will be there. Okay. And 1 meter will be equal to 1 meter will be equal to 100 centimeter. Correct? So it will become 10 to the power 7 dyne centimeter. So 1 joule is equal to 10 to the power 7 dyne centimeter. This is one formula. Beta. This is one formula. Now next important point. If that now 1 joule dyne is getting converted. So with a dyne centimeter is nothing but erg. So if somebody will write 1 dyne centimeter is equal to how many erg? So it will be considered as 1 erg. Remember this one. So 1 joule is equal to 10 to the power 7 erg. 1 joule is equal to 10 to the power 7 dyne centimeter. So dyne centimeter will get converted into what beta? Dyne centimeter will get converted into erg. So this is the most important part. In CGS system, it is 981 erg. In CGS system, it will be how much beta? 981 erg, or we can say that in CGS, this gram centimeter system, it will be 981 dyne centimeter. It will be how much? 981 dyne centimeter. So this is one part we have done. Now we have written all that sections. Now we are going to go for next question. So this is dimensional analysis of work done. Dimensional analysis of work done. You this remember beta. 1 kg meter. 1 kg meter, that is the work done. So 1 kg meter is equal to 981 joule. Understood? 981 joule. 981 joules. So 1 kg meter is equal to how much joule? 1 kg meter is equal to 981 joule. So dimension of work is dimension of force into dimension of displacement. Dimension of force into dimension of displacement. Okay. This is not needed, but this one is needed. 1 kilojoule is 1000 joule. 1 megajoule is 10 to the power 6 joule. 1 gigajoule is 10 to the power 9 joule. Beta. This is important. Kilojoule format. So what is the dimensional analysis of work done? The dimensional analysis of work done is ML2 t to the power minus 2. This is called as dimensional analysis. M is representing as mass L is representing as length and T is representing as time. So mass, length and time. Okay, I will do it little down better. Is it okay? I hope you might have understood. Now is it okay, beta? I have written all part. So 1 kg meter is equal to 9.81 joule. This you remember. 1 kg meter is equal to how much, beta? 9.81 joule. This is most important part. 1 kg meter is equal to 9.81 joule. And next part will be, somebody will be asking you, then you can be able to answer that what you call 1 kilojoule is equal to 1000 joule, and what megajoule is equal to 10 to the power 6 joule, and 1 gigajoule is equal to 10 to the power 9. Absolutely. So this is one of the most important thing. You must not forget this section. And our favorite part starts from here. Come on, start writing the first numerical for today. Come on, go for it. Force of 40 Newton. Answer is there with you. But please try this question out. How to solve this question? A force of 40 Newton act on a toy at an angle of 60 degree. Okay, act on a toy at an angle of 60 degrees. So that means what, better? Just now we have had a conversation. Now we were doing about the formula and we discussed that ki work done is equal to, so this is our formula F cos theta. Yes, now try this, try to solve this question, beta. So work done, components of work done is equal to this much is given. Now what is force given? Force is given as 40. Okay. So 40 cos, and what is the angle between them? Angle is coming as 60 degree. And what is the displacement? 12 meter. Understood. So force is exactly coming as how much? Force is coming as 40. Cos 60 degree value is 1 by 2. Cos 60 value is 1 by 2 into 12. 240 joules. Yes, got answer 240 joules. Direct here you don't have to do any big work. Here you have to direct apply and solve the questions. So this is exactly one of the most important thing. Here only work done we have used and we have just taken out the values. So this question was tough or easy, Peter? Direct application question was there. Very good. So when we are solving direct application questions, we have to substitute the value and get the answer. But I hope everybody might have understood. Now, can you see one thing here? Whenever we are talking tough or easy, my monkeys are saying, laughing. What happened? Understood. Super. Again, internet is going very stable, unstable, stable, unstable, stable, unstable. Now look at it. Let us consider the body of mass m when moving against gravity of height h. So mass is exactly going against gravity of height h. So we are taking the body of mass m upward to a height h. So this is a body of mass m upward to a height h, okay, and this is exactly the movement now from the ground. So let us consider the body of mass m which is moving against gravity of height. So we are taking the body of mass m upward to the height. So this upward height we are going to take it. After that only beta they are going to generalize the statement. The force acting on the body against gravity is F is equal to mg. Now I'm going to solve this beta. Just I'm going to explain you this part. Let's see. My voice is audible. Till now my voice was audible. Now let's see beta. So when we know that whenever an object is exactly going to come down and come up. So if I'm going to let the body fall down, just try and understand this. So here you try to understand this portion, ki weight of the body. So if the body, the force acting on the body against gravity. So when the body will be going against gravity means mostly the body will be going beta up or down. So you need to understand that ki when the body will be going up, it is against gravity, and when the body will be going down, it is exactly in favor of gravity. Understood? Now one question I am asking, one ball is there and one feather is there. Okay, if friction is not there, then which object from the same height I am throwing, then which object will hit the ground first? One ball and one feather. When one ball and one feather is there, beta, in if frictionless means atmosphere will not act as a friction or any other thing is not there, that time which one will fall first, the ball or the feather? Yes, this is the question I'm asking from you. In that situation, which one will fall first, the box or the, sorry, the ball or the feather? One feather I have taken, one ball I have taken from the terrace. I just thrown both of them together, but I'm knowing that the friction is not there. The friction is not there. Air friction, air is also acting as a friction na? If any lightweight object will be there, then friction will what you call try to oppose the motion of it to a more level, so definitely it will try to go down fast. The correct answer is both of them will hit the ground at the same time they will hit in absence of atmospheric pressure. Understood? In as the absence of resistance, they both will be, yes, they both will be hitting at the same time. They both will be hitting at the same time in absence of what? In absence of friction. Understood? Friction like air friction is there, opposing motion forces will be there. If it will not be there, then that part it is going to work like that. I hope you might have understood. So these are some things which is very, very important. Got it? So both will be hitting at the same time. Both will be hitting at the same time. So only I discussed this point. Understood not? Now we are going to discuss the next point. Yes. So till here we have understood. So now beta what we are doing is given the object is exactly going up. Now object is going up means it is going against gravity. So when the body will be moving like this, then force is equal to mass into acceleration. When the now understand, if I am moving on road like this, then force is equal to work done is equal to force into displacement. Understand? And force will be equal to mass into acceleration. So at the time when body will have vertical movement, means the body will have this movement, means the body will go like this, come back. So on horizontal ground only the body is moving like this. At that time the work done will be force is equal to mass into acceleration. Understood? But when the body will go up and down, at that time work done will not be considering force, here will be not ma, force will become mg. This kuti g is acceleration due to gravity. What is that kuti g beta? The kuti g will be considered as acceleration due to gravity. That means this part is when the body is exactly moving, having horizontal motion. But when the, yes, acceleration due to gravity, when the body will have what beta? When the body will have upward, like up and down, through like this reaction will be there, means the body will go up like this, go down. At that time, force will be equal to mass into gravity. So this small g is called as kuti g is acceleration due to gravity. Acceleration due to gravity. Understood beta? So acceleration kuti g will be what? Kuti g will be acceleration due to gravity. Understood? So here this kuti g is what? Kuti g is acceleration due to gravity beta. Got it? So this part will be acceleration due to gravity. So when force will be, so here beta you need to remember this. So when the body will be going up, so once the body will be going up, now gravity will be negative. So look here how the formula is coming. Force will become mg. Check here, when the body is going up, force work done is what? Work done is equal to force dot s. Now dot product means fs cos theta will come. Force will become mg, mass into gravity, because the body going up and down, mg will act up, acceleration due to gravity will go down. Now here mg is coming, s is the total height, because beta whenever any object is placed up and down, here it is not about displacement, then it will become height, because I'm throwing from certain height now. So that time, rather than displacement, what will be more accountably called is as height. Okay, so here displacement will be replaced by height h. Now cos theta value, it is more than, see, it is going more than 180 degree now. So cos of 180 value is, because see the body is moving from here to here, so it is coming as how much beta? 180 degrees. So it is coming as minus mgh. So if any object will be exactly going up, the force, the work done will become what beta? Minus mgh. Remember, because how much angle this is making? This is making 180 degree. This is the most important point to be remembered. So the angle what it is exactly making is 180 degree, because straight away na, so this is exactly coming as 180 degree. The object is going up. So when the object is going up, what and all things are exactly going to happen? Let's check this one out. So see, when the object is going up, means it was here and it is going up. So this is the height. Now what is work done formula? Work done is dot product of force into displacement. So work done will be equal to force into displacement into cos theta. Now here, the straight line it is moving. So angle theta is coming as 180 degree, because you see this is total one straight line now, so 180 degrees coming. So here we will write force will be what? Force formula, when going up and down, force will be considered as mass into gravity. So force will become mass into gravity, and this is the displacement, and displacement is nothing but h. So instead of s we will write h. Now beta, cos of 180 degree, I told you in that table cos of 180 value is minus 1, so it will become minus mgh. Understood? So this will be considered as how much beta? Minus mgh. This is the case when the object is exactly placed up. That time it will be coming as minus mgh. Now we are going to talk about when the body will be falling down. So if the body will be falling down at that particular moment, what will be the work done? So now look here, how we are going to write it. Minus mgh is for up. Now down means force will be equal to mg again, correct? This time the body is going down beta. So here, since it is going down, gravity, acceleration due to gravity will be considered as positive only, it will become plus mgh. So displacement will become again same height h. So work done will be equal to mgh in that case. Understood? Because gravity will be positive, same angle 0 degree will be there, so answer will come as positive here. So you must remember this one. Going up object, it is work done is coming as minus mgh, and going down work done is coming as plus mgh. So this is the difference between when the object is going up or the object is going down. I hope everybody might have understood what I'm saying right now. So this was about positive and negative work done. Let's see. Now beta, same product. Now if somebody will be asking you what will be the case when the body, so when the body will be dropped down, at the case when the body will be dropped down, yes, understood na nicely beta. So when the case when the body will be dropped down, the work done will be positive or negative or zero. Same situation will be there beta. So work done will be exactly coming as Fs cos theta, mgh here cos theta, angle between force and displacement. What is the angle beta? Force is in the direction of displacement. Here now one thing must remember. See here, first case, force and displacement. Here force was in the direction of displacement, force was away from the direction of displacement now, because gravity was trying to push it and the object is going up. So because of that, what angle they were making? They were making theta is equal to 180 degree. Understood? At that particular moment, what angle they were making beta? They were making angle theta is equal to 180 degree. But now when the body is going down, force is in the direction of displacement. So since the force is in the direction of displacement, here force is against the direction of displacement. Here force is in the direction of displacement. So once the force will come in the direction of displacement beta, work done will be what? Displacement part will become positive. Understood? So here it will come as how much degree? This will come as 0 degree. So now when it is coming as 0 degree, so now what we are going to write? Work done is equal to force into displacement. So it is coming as F cos theta into S. Understood? F cos theta into S. The moment it is coming like this, now cos theta, because force and displacement are in the same direction. So whenever force and displacement are in the same direction, angle subtended between them will become 0 degree. Upside angle subtended is 180 degree. Upside angle subtended is 180 degree, because force and displacement were opposite. Force and displacement were opposite. But here force is in the direction of displacement. So when force will be in the direction of displacement, here theta will become 0 degree beta. So it is coming as Fs cos 0 degree, and cos 0 degree, when angle will be there, value is 1. So it is coming as Fs. Now what is F? F is mg, and what is S? S is height h, because the body has to cover what height? H height. So this is exactly the content we have studied. So here we have understood that if any object will have free fall, so what will be work done? When the object is having a free fall, then what is the work done? Come on, say. Who can say me this answer? I hope everybody understood this part. Come on, till here it is done or not, beta? So here mgh is there, and that is minus mgh. So one will be plus mgh, another will be minus mgh. So these two things were there. One is 180 degree. Force is in the direction of displacement when the body is exactly going opposite upside. When body is going downside, force is in the direction of displacement, so it will become negative. So work done on going, letting it go up, work done will be negative, and when the body will be going down, work done will be positive. But beta, did you notice one thing? Did the formula changed? Did the formula change, children? Can you tell me? Did the formula changed? The formula remains same only. And what was the formula, beta? The formula was mgh. So work done was mgh. Only negative and positive is there. So when the body will be exactly going up, the work done was negative. When the body was going down, the work done was positive. Okay, can you tell me 1 joule is equal to how much erg? 1 joule is equal to how much erg? Come on, it's time to start answering the question. 1 joule is equal to how much erg? We studied one thing. 1 erg is equal to 1 dyne into 1 centimeter. 1 erg is equal to 1 dyne into 1 centimeter. Thank you so much for liking the class. 9 erg, how can it be 9 erg, beta? Think nicely. Mhm. I taught this part. We have studied that section. Come on, go for it. Say, 10 to the power 7 or 10 to the power 5? Hmm? 10 to the power 7 or 10 to the power 5? What is the correct answer? Aro? 10 to the power 7. 1, 2, 3, 4, 5, 6, 7. 10 to the power 7. So it is coming as 1 erg is equal to 10. So 1 joule is equal to 10 to the power 7 erg. 1 joule is equal to 10 to the power 7 erg. That's the correct answer. 1 joule is equal to 10 to the power 7 erg. Very good. 1 joule is equal to 10 to the power 7 erg. So this was, and what is the unit of what you call SI unit of work done? The SI unit of work done is joule. Okay. Now work done dimension, the work done dimension is ml to the power 2, t to the power minus 2. Work done is a scalar quantity or a vector quantity. Then we studied work done is exactly a scalar quantity because it is the dot product of two vectors. Dot product of two vectors. Dot product of two vectors is always scalar. Yes, work done is dot product of two vectors. Always remember, work done is dot product of two vectors. Remember this one. Force is a vector quantity and displacement is a vector quantity. Work done is dot product of two vectors. So since work done is dot product of two vectors, it is a scalar quantity. Always remember, force is a dot product of two vectors, so it is a scalar quantity. I hope till here everybody understood. Till here done? Okay, super. Okay, fine. So we're going to keep it till here because our slides are finished here. So next class tomorrow, maths class will be there. Now work done another part we are going to understand, power we are going to understand, and we will be doing the numericals of that session beta. Okay. So see, because of network, rain, these problems are coming, but then too I'm keeping the classes beta. Oh ho! Today this monkey is so keen to say me bye bye. This much sweetly telling bye bye. No fighting. Wow. Okay, bye bye. Today the monkey is very nicely telling bye bye means there is some problem. Thank you for liking this session, beta. Bye bye.